We want to solve the system of equations by graphing and verify your solution. So we have y equals negative 2x minus 3 and x minus 2y equals negative 4. The first equation is in slope-intercept form, y equals mx plus b. So that means that in terms of graphing, we can easily identify our slope m as negative 2 or negative 2 over 1 and our y-intercept as the coordinate point 0, negative 3. We have slope-intercept form. So to graph, we're going to plot the y-intercept on the y-axis down here at negative 3. And we're going to apply our slope to find at least one other point. Since our slope is rise over run, but we have a negative 2, that means we're going to fall. We're going to go down 2 units, and then we're going to go to the right 1 unit. So that is one other point on our line. But let's go ahead and try to find some other points that are over here on the left side of the y-axis. Instead of thinking as our slope as negative 2 over 1, we could also think about it as positive 2 over negative 1. So now that the positive 2 is on the top, that's the rise. We're going to go up 2, but this time we're going to go left 1 because of that negative 1. So we'll do it a few more times. Up 2, left 1, up 2, left 1, up 2, left 1. And we'll connect these points with our straight line. So this is our first equation, negative 2x minus 3, graphed. Now our second equation, x minus 2y equals negative 4, is not in slope-intercept form. So let's practice rewriting it in slope-intercept form, and then we'll graph it using the same method as before. So we're going to try to solve for y. We're going to subtract x from both sides. So we have negative 2y is equal to negative x minus 4. So I'm choosing to put the negative x in the front to make it look like mx plus b. Now I need to divide both sides by negative 2. So negative 2, negative 2, negative 2. Divide each term by negative 2 on both sides. So I end up with y is equal to positive 1/2 x plus 2. So I have that mx plus b form. And so I can recognize the slope m is positive 1/2 and the y-intercept is 0, 2. We'll graph our y-intercept on the y-axis at 0, 2, and then we'll apply our slope. So our slope of 1 over 2, rise over run, would send us up 1 unit and right 2 units. Well, we actually want to find the point of intersection to solve the system of equations. So instead of going up and right, I want to think about going down and left, since positive 1/2 is also the same as negative 1 over negative 2. So we can think about going down 1 and left 2. So we can see that point of intersection is going to happen at negative 2, 1. So we'll graph our line. And the point of intersection is the solution to the system of equations. So that's negative 2, positive 1. Now our job is to verify that that is the solution. So to verify that negative 2, 1 is the solution to the system of equations, we have to plug the x and the y value into each equation and make sure it produces a true statement. So let's start with the first equation here. I'm going to replace y with 1. So I'm going to have 1 is equal to negative 2 times negative 2. I'm going to replace x with negative 2 minus 3. So 1 is equal to 4 minus 3, or 1 is equal to 1? Yes. So we were questioning whether that was true, and it is. 1 is equal to 1, so we end up with the true statement. And now we'll do it for the second equation. It has to satisfy both. So we'll replace the x value with negative 2. So we have negative 2 minus 2 times 1 is equal to negative 4. And we're questioning that. And so we have negative 2 minus 2 equals negative 4. It sure does. Negative 4 is equal to negative 4. So we have